We already talked about the profit maximizing monopolist who does not price discriminate and is not regulated. And we discussed the fact that the monopolist graph is like a combination of these two graphs for perfect competition. We take the demand curve from the perfect competition graph and basically move it over to the individual firm's curve, because in monopoly there isn't a whole market full of suppliers. There's just essentially one farmer or one supplier. So we move the demand curve. We get rid of AVC because it's not as relevant, although it is still a shutdown point for monopolist. We're just not going to show it on every graph. So we have the demand curve here, marginal cost, ATC, and then we added in this marginal revenue curve, which is steeper than the demand curve, because when the monopolist lowers the price in order to sell more units of a good, they must lower the price on all units. So if they lower the price from 10 to 9, marginal revenue will drop even lower. It won't just drop by $1, it would actually drop by, for example, $2. If they were selling one unit at $10, now they're selling 2 units at $9, the marginal revenue would only be $8. So we discussed that before, and we also discussed the fact that the monopolist will choose not to produce in the inelastic region of the demand curve, because in the inelastic region, if the monopolist continues to expand output, revenues fall, and of course costs rise, so there's no way that that would be profit maximizing. The monopolist, back to this graph for just a moment, the monopolist's profit maximizing point is where marginal revenue and marginal cost are equal, just like with any kind of firm. So this will give us the profit maximizing output, and then to find out the price the monopolist would charge, we draw up to the demand curve, because that tells us what price the market will bear with that quantity of output, and then we draw across here, okay, and that gives us the price the monopolist would charge, and this is the output that the monopolist would produce. And we can compare that to what would happen in perfect competition when essentially supply, which is the marginal cost curve, crosses demand. Okay, this is how much a perfectly competitive market would produce, and the price would be much lower, right? They'd produce more and they'd sell it for cheaper. So that's one of the problems with monopoly. All right, so what we didn't do before is we did not talk about price discrimination, and we didn't talk about natural monopolies. So price discrimination, if monopoly can price discriminate, that means that they can charge each buyer exactly what that buyer is willing to pay. So in other words, this marginal revenue line actually becomes irrelevant, right? Oops, not letting me get rid of it. That marginal revenue line disappears because each individual purchaser, the first person to purchase this, say, pays $10, right? And the second person to purchase it pays $9. So marginal revenue is actually $9, right? The third person pays $8. Marginal revenue from selling the third unit is $8, because they don't actually have to reduce the price on previous units. So price discriminating monopolist is able to sell to every individual at exactly the price that they value the good at, the most they'd be willing and able to pay. So the output level actually ends up being higher than in a traditional monopoly, because marginal revenue doesn't fall, right? The point where marginal revenue equals marginal cost is way out here, the same place it would be in perfect competition, because the marginal revenue of this 10th unit, the amount that person is willing to pay, is equal to the marginal cost of production. So price discriminating monopolists are actually allocatively efficient. Consumer surplus, however, completely disappears, because every consumer is paying exactly the amount which they value the good, so there's no surplus left over for them. The monopolist gets all the surplus for themselves. There are also two other kinds of price discrimination: second and third degree price discrimination. Second degree price discrimination happens when the monopolist, or actually this can happen in things like oligopoly as well. It doesn't have to be. Even in monopolistic competition, you might see second degree price discrimination. But what happens is bulk discounts, meaning people who want to buy just a little at a time are faced with one price. We'll call that price P1. But people who are willing to buy a large amount at a time, right, are given a different price. So you get a discount for buying a lot. And they can actually offer these two different prices. Now, it's possible that the bulk buyer will buy a lot and turn around and resell it at a higher price. But the monopolist doesn't really care, because it's actually saving them as well, right? Their average total cost is lower. out here. So essentially, rather than being able to charge every individual what they're willing and able to pay, they chop the market into two segments. People who, for example, want to buy gum by the individual pack, and people who are willing to buy 3 packs of gum at a time. The people who are willing to buy more at a time, they get a little bit lower price. And this is sort of the principle of Sam's Club and Costco. Third-degree price discrimination requires actually basically physically separating buyers into separate markets with separate demand curves. And in this case, plane tickets are really the best example, because there are really two different markets for plane tickets. There's the tourists, the casual travelers, right? And then, sorry, it's really hard for me to write with my mouse like this. So you have the tourist travel, and then you have what I'll just call the business travel, B-I-Z. Okay, you have the biz travel. And the tourists have a very elastic demand curve like this, right? Because if tickets go on sale, they're a lot more willing to buy them, and if they're expensive, they're a lot less willing to buy them. But business travelers have a more inelastic demand curve because they pretty much, if they have to be in New York, they have to be in New York. So the key for the airlines or for the travel agencies is to figure out how can we tell them apart. If they get on our website, how do we tell if they're a tourist or if they're a business traveler? And one of the ways they do this, of course, is by offering different classes of seats, like business class versus economy. But another way they do it is by charging less to people who buy plane tickets with a Saturday night stay. Because business people want to be home on the weekend, but tourists are perfectly happy to still be on vacation on the weekend. So they can actually segregate, and they're very lucky because the law actually makes it impossible to resell plane tickets. So they can really separate the two markets. And once they've identified you, if you're a tourist, you're going to probably get lower prices, right? Because you are buying in this market with a more elastic demand curve. Business people are going to face higher prices. Okay, so that's second and third degree price discrimination. Problems with monopoly, as I said, they charge too high of a price. They restrict output. They reduce total surplus, and in some cases, dramatically reduce consumer surplus. They tend to under-allocate resources, so it's allocatively inefficient because not enough is being produced. They also tend to produce to the left of minimum ATC, so they're also inefficient productively. What can be done? We can pursue antitrust charges, we can ignore them, we can regulate them. And the one we're mainly going to talk about here is natural monopoly. Because natural monopoly is a little bit different from other kinds of monopoly. Natural monopoly is created when there are major economies of scale, meaning very, very high startup costs, something like an Xcel Energy or a cable company. It's very expensive to start it, but the more customers you have, the more you can spread those fixed costs over lots and lots of people. And ATC, as you can see here, ATC continues to drop over a long period of time. So rather than seeing an ATC curve that looks like this and a marginal cost curve that goes up quickly, what we see is ATC continues to drop for the entire duration of this graph, and MC has yet to cross it, because they just get more and more efficient the larger they get. And that's why they're called a natural monopoly. And we don't want to break up a natural monopoly, because if we did, if we had lots and lots of small producers, right, if they're only producing, say, this much, okay, let's say they're only producing that much, their average total cost would be way up here. So there wouldn't really be much of a savings to consumers, because the firms would have to charge more than P1 just to break even. So we want to keep the natural monopoly, but we want to figure out a way to prevent them from ripping off the consumers. So what we do, there's two ways to do this. One is what's called socially optimal pricing. And this was sort of the original idea of regulation, was that the Regulatory Commission wants allocative efficiency, so we will require the monopolist to produce where the price equals marginal cost, right, which is right here. Okay, this also gets called marginal cost pricing. It's socially optimal because it is, in fact, the price that would arise in perfect competition. And we say the regulator will impose a price ceiling, okay, at this socially optimal price. So we put a price ceiling here, and we say the price can't go above this. But what's wrong with this? If you look at the picture for a minute, you'll see that this price is actually below ATC at this level of output. Well, that means that we're forcing the monopolist to take a loss. And they're either going to go out of business, or we're going to have to subsidize them. So socially optimal pricing doesn't really work out too well in the real world. It's actually very rare, because the Supreme Court in the United States ruled that monopoly owners, such as utilities, actually have the right to a fair return on their investment. So instead, regulatory agencies now set what we call a fair return price. And the fair return price is where the price is set equal to the ATC. And basically what we do is we look for where ATC crosses the demand curve. Okay, and so we can see that people are willing to pay that price, and this monopolist is able to break even. So we set the fair return price ceiling. This becomes the level of output, okay, and that becomes the price that's charged. And compared to how the monopolist would behave on his or her own, producing Q1 units of output and charging P1, we can see they produce a lot more and they charge a lot less. And regulatory commissions exist to actually enforce these. So if a company like Xcel wants to charge its customers more, it actually has to go to a regulatory commission and ask for permission to be able to raise its price. So what's fair about fair return pricing? What's fair is the monopolist actually gets to have a normal profit. So the entrepreneur is getting paid as much to run Xcel, for example, as they would get paid to run anything else or to be in their next best option. So this does achieve the goal of lowering prices and increasing output. However, because we're not all the way over here at the socially optimal price, we're still not allocatively efficient. Okay, if you look at this sample problem, this gives you a little bit of practice. You should be able to look for what price the monopolist would set. What the monopolist would do is they would choose to produce Q2 units of output, but as I said, they would go up to the demand curve and they would charge P2, right? So Q2 units of output, price of P2. If the monopolist could price discriminate, you want to remember that they're going to keep dropping the price along the demand curve, right, until they hit marginal cost. So if the monopolist could price discriminate, they would set a price of P5. The socially optimal price is also P5 with an output level of Q5. And a fair return price is this price, P4, with an output level of Q4. Okay, this one is a lot of fun. You should take a look at it in the notes and see if you can figure out the answers to this one. All right, that's where we're going to end for these notes.